Let's learn about one of the most fundamental integration techniques, integration by parts. Now, after first semester calculus, we really learned two integration techniques. The first integration techniques is what I call change the way it looks. And we primarily changed the way things looked using algebra. The second integration technique that we learned in first semester calculus was what I call U-Substitution. Now, this second technique, U-Substitution, it really undoes the chain rule. Okay? So in this particular section, we want to learn a new integration technique that will undo the product rule. So let's remind ourselves of how the product rule works. So if you were to take the derivative of the product of two functions, f times g, and I'm going to put a prime in parentheses to represent, you're taking the derivative of the product. The way that that worked was you took the derivative of the first function f and you multiplied by g, and then you added what you got when you took the derivative of the second function g and multiplied that by f. Okay, so this was our product rule. Now, I can manipulate this a little bit, so I can rewrite this equation as follows. I could rewrite this as f times g prime is equal to g times f prime plus f times g prime. So all I did was I interchanged the order of f prime and g, and I interchanged the order of g prime and f. Now we're going to manipulate this formula a little bit using algebra. So let's rewrite that as fg prime is equal to fg prime minus gf prime. Okay, so all I did here was I took this gf prime, I subtracted it from both sides of this equation, and I sort of flipped the two sides of the equal sign. What I want to do next is I want to integrate both sides. So I am going to integrate both sides. So I got the integral of fg prime is equal to the integral of fg prime minus the integral of gf prime, like that. And one of the things that we'll notice is if you look at this term right here, you're having a product, you're taking a derivative, and then you're finding the antiderivative. So we know that that would result by the fundamental theorem of calculus, all you get is just fg back, right? So then this becomes the integral of fg prime. You're going to get fg minus the integral of gf prime. Okay, so basically what we've done is we've just derived the integration by parts formula from the product rule. Now, traditionally, we call this f equal to u, and that means that f prime, we call that du, and then we usually call g prime dv, and that would make g equal to v. So when we go to write our integration by parts formula, we usually write it with the u's and v's. So the formula is basically integral of u dv is equal to uv minus the integral of v du. And I'm going to highlight this because it is important to us. This is definitely something that we want to memorize, okay? Now, the hard part is choosing u and dv. All right, so you have to look at an integral, and one piece of your integral you're going to choose to be u, the other piece of your integral you're going to choose to be dv, and then you're going to apply the formula. And the hope is that the resulting second integral you get is supposed to be easier. That's the hope. So what we're going to do is we're going to work through example 1, but we're going to kind of do it twice. So let's take a look at this integral that we have right here. I need to choose part of it to be u and part of it to be dv. So when I do it this first time, I am going to let u be equal to sine of x, and I'm going to let dv be equal to the rest of the integrand. In this case, that will be x dx. So usually the dv part will have something and then a dx in there, and the u should be the rest of the integrand, so that when I look at the whole integrand and multiply together, I get u dv. Now, what I want to do is I want to differentiate the u part, so I'm going to get, du dx, and that's going to be equal to the derivative of sine. The derivative of sine x is cosine of x. And to be honest, we usually do not write it like this. We usually move the dx up. So I'm going to erase this dx. I'm going to put the dx with the cosine. And then to find the v part, we're going to find the antiderivative of dv. So when I find the antiderivative of x, I'm going to get x squared over 2. And we're not really going to worry about adding that constant c. We'll just throw on the plus c at the very end. Okay, so now this actual question is the left side of our integration by parts formula. And I'm basically going to use what I've just calculated over here to fill out the right side of the formula. So when I do that, I'm going to get uv, which we could write as x squared over 2 sine of x. Again, I probably interchanged the order there. uv is the same thing as v du. And I'm going to get minus, now I'm going to write the v part, which was x squared over 2, and then the u part. The du part, which is cosine of x dx. So when you look at the resulting integral that I get, I now have to integrate this thing. And when you look at this, this looks even worse than my original integral, right? Like at least my original integral only had 1 power of x. Here now I have a x squared over 2. So when you see that your integral actually looks worse, this is a indication that we actually made a bad choice of u and dv. So I'll write that. Integral looks worse. Looks worse. Maybe this is a bad choice of u and dv. So instead of doing that, let's make a different choice. So why don't we have u be equal to something else? Instead of having u be sine x, why don't we have u be just x? This basically forces our dv to be the rest of the integrand, which is sine x dx. Now we need to take the derivative of u. So the derivative of u is du, and the derivative of x is 1. So we can just write that as 1 dx, or just dx, like this. We need to find the antiderivative of sine of x. So the antiderivative of sine of x is going to be negative cosine of x. Okay. And when we apply our integration by parts formula this time, the uv is going to be negative x cosine of x. And now we're going to subtract what we get when we have the v du. So we're going to put my integral. My v was negative cosine of x, and my du was just dx, like this. So this time, when I look at the resulting second integral, this is much easier to integrate than this guy, and it's definitely much easier to integrate than the original integral as well. So this is a sign that we're on the right track. Okay. So we know that a negative times a negative is going to give you a positive. So let me just change these guys to a plus, like that. And let's rewrite the first part of our integration by parts formula, which was x cosine of x. That part stays there. But now I want to find the antiderivative of cosine of x. And the antiderivative of cosine of x is just sine of x. Okay, so we've now completed finding the antiderivative. We just need to tack on a plus c because we want the most general antiderivative. And let's highlight this because this will be our final answer. Okay, so I hope you enjoyed this introduction to integration by parts. We'll do more examples in class. Take care, everyone.